Today I'll make a pencil, but not from wood. I will melt down a few pencil sharpeners and I will try to embed a graphite core inside of the pencil while I do the casting. And I'll do it all by using an ordinary kitchen microwave. I started by designing and printing a simple PLA pencil. I want to embed the graphite core inside of the pencil when I do the metal casting. So I took a core and I inserted it into the pencil. Pencil cores are made from graphite and clay mixture. I'm hoping when I pour hot aluminum over it, it's not gonna get damaged. Here I'm using some cheese wax to attach the pencil to the flask's bottom. All the flasks I use are 3D printed and made specific size. They're made for my vacuum cleaner vacuum casting setup. This is the size 3 flask. The reason I'm calling it size 3 flask is because it's made to fit 3-cup coffee maker funnel, this coffee maker. I also use 6-cup, 9-cup or 12-cup funnels to vacuum cast even bigger molds. And here I'm using some Vaseline so I can remove the base without breaking off the feet. More on that in a second. Cheese wax is soft. I like to stick it in a freezer for 10 minutes before covering it with plaster. The size 3 or 3-cup mold is the one I use the most because it's the quickest one to burn out. The investment I use the most is plaster of Paris mixed with sand and water. To minimize the bubbles, I like to use one of my favorite tools. I left the mold to sit for around an hour and 20 minutes before opening it up. If you wait too little or too long before opening up the mold, you risk breaking off the feet. It also depends on the investment you use. The feet are there to raise the mold a little bit to help the burnout process. Next I clean the edges and if I can, I recover some of the wax. Next I'll put it in the oven between 2 and 3 hours. This plaster mold has been in the oven for around 2.5 hours. Now it's ready for the next stage, microwave kiln. Inside of the microwave kiln you'll find silicon carbide. Silicon carbide absorbs microwaves and turns them into heat. I'll show you how to make this microwave kiln in one of my upcoming videos. The reason I used oven first is to get rid of most of the moisture. I don't like to put wet molds inside of my microwave kiln because it can get damaged. Before I start the burnout, there's one more thing I need to do. Microwave kiln will produce the heat just like other types of burnout ovens. Unfortunately, there's one thing present in the microwave kiln that you won't find in electrical wire burnout ovens. What's that? Microwaves. Microwaves will negatively affect your molds. They will make your molds crack. So what's the solution? I'm gonna use aluminum foil. Oh, and before I forget, I like to scratch the bottom with a wire brush. I'm using a 3D printed roller to transform the aluminum sheet into aluminum mesh. It will protect the mold and let the moisture escape. I'll put it on top of aluminum sheet and into the microwave kiln. The burnout procedure is pretty much automatic. I just need to set up the microwave and in 4 to 5 hours the mold will be ready to cast. But how do I control the microwave? Obviously I don't just turn it on and let the microwave kiln reach 800 degrees Celsius. That would totally destroy the mold. The answer is one of these. It's a cycle timer. You plug in whatever you want and you choose how many minutes it's gonna be on and how many minutes it's gonna be off. And then the cycle will repeat. And it works like a dream. Normally I don't touch the mold until my estimated burnout time has passed. I wanted to show you the burnout cycle in progress. That's why I opened up the kiln a little bit earlier. I'm gonna use the opportunity and throw away the bottom aluminum foil together with some unburned plastic. At this stage, I usually remove the foil and turn the mold upside down for any gases to escape. In this case, I didn't do it because of the graphite core. I didn't want to break it, because graphite also absorbs microwaves. I'm gonna melt these pencil sharpeners inside of my microwave. Just like with microwave kiln, silicon carbide will heat up. In this case, the crucible is made from silicon carbide. I will show you how to make your own insulating chambers and crucibles in another video. And here I'm setting my vacuum cleaner vacuum casting station. Of course, it's not as good as a proper vacuum casting equipment, but it does work pretty good for basic casts. The burnout process has finished. I'm gonna remove the kiln and put it on the floor. The mold inside will stay nice and warm until I melt the metal. The temperature of the mold is probably between 350 and 400 degrees Celsius. So it's not as hot as you would have it in traditional lost wax casting. I could bring up the temperature if I wanted to, but for this simple cast I feel like it's not necessary. Melting that much aluminum in a new chamber would probably take around 5 minutes. It took me a bit longer this time because my chamber has been used a lot and it's not as efficient anymore. I'm gonna prepare the mold to pull the vacuum. Another reason why the temperature of my molds is on a low side is because I don't want to burn the silicon sleeve. I'll go into more detail about the vacuum casting process in another video. And by the way, I know I'm not wearing proper safety equipment. I'll make better mistakes tomorrow. In my defense, I have done it hundreds of times, and I actually do wear more safety equipment when I deal with larger quantities or different types of metal. At least I try to. The mold has cooled enough to remove the silicon sleeve. This way it's ready for the next cast. Alright, let's open it up and see what we got. The metal pencil looks pretty good. It's not a perfect cast, but it's good enough for me. And here's the graphite core that was outside the pencil. Let's see if it worked. Oh yeah! Time to clean it up before I try to sharpen the pencil. I could have kept sanding to get rid of those casting imperfections, but I didn't because I think they look quite cool. To make the sharpening easier, I printed out a handle. This was definitely the hardest pencil I have ever sharpened, and I hope I won't need to do it again. I did change the blades on my sharpener twice, because I do have some extra blades, I wonder from where. Nothing goes to waste. A few blisters later, we succeeded in sharpening the pencil.